Hey, welcome back. Let's talk about another classic problem, number of islands. So given a 2D grid and map from 1 and zeros, 1 is islands and 0 is water, return the number of islands. So we are given this grid, and the islands is surrounded by water, is formed by connecting adjacent islands horizontally or vertically. And you may assume that all 4 edges of the grid is surrounded by water. And so basically we're saying 1 represent the islands, and 0 stands for water. And I want to know like how many connected islands we have. So one example is that this guy. So all the 1 are connected. So those are 1 connected islands. And the second example we have 1 group of islands. So those counted as 1 island. And this guy is isolated as 1 small island. And we have a island connected with it too. And we have all those. Okay. Those are the examples, and this is a very classic problem, and we're gonna solve that by using BFS. But my favorite way to solve this is actually by using DFS. Since this week we're covering BFS, let's go ahead and solve by BFS. But in the following weeks, I'm gonna talk about some different type of solutions for this problem. Now we can start writing this. So we need a result to storing the result, and we need to define the boundaries as well. And the boundaries defined by the grid. And we have the rows and columns, and we also need to do something like this. So how do we tackle this? Like, let's figure this out before we actually write in the code. We need a result to recording how many islands we have, and then we looping through everything. We looping through every single node within this grid, and we check. So if this guy's 1, and then we start exploring. It's very similar to the previous problem we did, surrounded regions, right? So we explore one of the node, and then we explore all the neighbors it has. So if this neighbor is also an island, so we connect them. We connect them by change this guy to 0, change this guy to 0 as well. And we the islands we explore connected with this guy, we change all of them to 0. That means when we explore all the way to here, we don't have to double count this island because this guy is already connected with this guy. So we count the entire bigger island as 1 island. And that's why we switch this guy over 0. Switch this guy also over 0. And all of this connected component will become 0. And when we switch all the way to here, like when we're looping all the way to here, and this will already become 0. So we don't have to double count this as an island because we already counted at the first one. And that's how we do it. And same thing right here. So the second example, once we loop here, we're gonna switch all the 4 value 1 to 0. And we no longer have islands around this corner. And when we sweep all the way to here, forget about it because we already counted. And then once we loop all the way to here, and we're gonna count one more time. But this guy does not have any family islands. So we're gonna swap this value to 0 as well. And once we swap all the way to here, sweep all the way to here, and we change the value to this guy to 0, and this guy also to 0, and both of the value become 0. And once we loop all the way to here, and this already becomes 0, so we don't double count it. So in this case, we have 3 different islands. That's how we're gonna solve it, and that's how we're gonna write the code as well. And just like the previous problem, we're gonna define the directions very standard with the BFS. Let's go ahead and write all the 4 directions. 1, 0, and 0, 1, and 0, -1. So we're gonna sweep all the 4 directions, and then we're gonna loop through every single node we have within this island. Let's do that. And we're gonna check, hey, if this guy is an island. So how do we check that? Island is represented by 1. So we just check if this guy is 1 or not. If this guy is 1, perfect. So we're gonna do BFS, and we're gonna pass in the grid, and we're gonna pass the coordinates. So and then result +1. So this will be in place modification within this grid. We're gonna modify all the connected components to a different value, which is 0. And then once we go up to the next value, and the value will no longer be 1, so we don't double count 1 island to multiple islands. and that's always obvious. But we can do this with the BFS as well. So all we have to do is switch the value, switch the helper function. So now we define the helper function as the BFS. Okay, so now let's return the result, and we can start writing the BFS. Oops, it's not grid. It's not board anymore. So we pass INJ as our coordinates, and we and we put our boundary here as well, and we need to initialize a Q as our BFS. And this is gonna be a DQ, double-ended Q, and we're gonna put the initial position right there. Okay, perfect. So, and then we're gonna put a while loop, and the while loop is gonna be, we pop out the node from the BFS, very standard, and we're gonna deal one node at a time. And we pop this guy out, and this will become INJ, and this our coordinates. And we don't have any operation terminated position, so we don't have to deal with that. And all we do is explore all the neighbors we have. So we explore all the neighbors we have. Oops, sorry. So that's why I put my directions as a static variable, because I'm gonna access that from my helper function. And once we have that, we have to define the x and the y. Y will equal to, oops, j plus dy. Okay, perfect. So that's our neighbors, and we're gonna check if our neighbor is out of the boundary or not. If x is less than 0 or y is less than 0. Sorry, my slow typing. So, or x greater or equal to m, or oops, what I'm doing here. And y is greater or equal to m. Okay, so if that's the case, we're just gonna continue, and we're already done with that. So if it's out of boundary, we're already done with that, so we don't have to do everything about it. And another case is that if this guy is the new value, right, the new position we are trying to explore is already 0, and then we can skip that as well. We don't care about 0, we don't care about islands. And what's the next thing we have to do? The next thing we have to do is we're gonna put this value, the new value, back to the queue, and we're gonna start exploring all the neighbors, all its neighbors. And one more thing is, we're gonna modify the degree to 0, because we don't want to double count it. So once we put this there, so we can put this back to the top as well. Depends on what kind of like the style you like. Okay, so I think that should work. Let's go ahead and run it. Oops. Okay, perfect. So yeah, so I just did a few minutes ago, and let's recap the algorithm, right? So we are exploring every single node we have within this grid, and we are checking, hey, if this guy is 1, it's an island, but we have a whole bunch of connected components, but they are counted as one island. So which means I need to do either BFS or DFS to put all its neighbors to 0, to convert all its neighbors to 0. That means like everything connected with this guy, if you are 1, you have to convert it to 0. And we don't double count you. So eventually we're going to return 1 from this case. And that's how we do it. Okay, sounds great. I'll see you guys in the next video.